Okay, our last day of algebra review here for geometry, and we are going to look at our quadratics today. We're going to remember how to factor. We're going to remember how to solve quadratic equations. If you look at our lesson focus here for today, again, it tells us to factor those polynomial expressions, completely, though, is the key word here, right? That means remembering all the different ways to factor, but making sure that we check more than one way in every problem just to make sure that we get it all. All right. So the other thing we're going to talk about then is to remember how to solve quadratic equations with all of the methods, square roots, factoring, as well as the quadratic formula. And when we use the quadratic formula, we remember that we have this thing called the discriminant to figure out how many solutions that we have in a problem without having to do the whole quadratic formula. All right, so that's our goals for today. So if we move on down, let's see, starting with our warm-up, hopefully you can tackle this without watching. This is just going to match up the different ways we have of factoring with the number of terms that we need. So you can rearrange the green boxes if you want to, and then just match them up with the yellow boxes. So I made a table for you, so put the green boxes wherever you want, and then match the correct number of terms that you need for that method of factoring. Go ahead and see if you can do that. All right, this one is going to be a little bit tricky for me to do because I can't actually move things around on my program I'm using to take the notes for you. So I'm just going to keep the green ones in the same places. So let's say that this green one is just going to go right here. So the binomial guess and check. Some people call this the factor box method. Some people have the X method. The binomial guess and check is the one that you use for trinomials. So trinomials require us to use 3 terms. So a binomial guess and check is something that you do with 3 terms. These are for trinomials only. Okay. That's the one where you put your 2 parentheses, sets of parentheses down, and you try to figure out what goes in them. All right, the next one that we have, let's say grouping, is going to go right here. So grouping is the method you do with 4 terms. That's kind of repeated greatest common factor, is the method called grouping. The next one we have is actually greatest common factor, or factoring by GCF. GCF is the most common way that we can factor, and you can look for GCF with any number of terms. So any number of terms is what lines up with GCF, and that's why it's the one that's used most often and the one that we always need to check to make sure that we do no matter what. Even if we do other methods, always check for that GCF. All right, then let's say we've got the difference of 2 squares, otherwise known as dots. The key to the number of terms needed was right there in the name of that one. Difference of 2 squares, we need 2 terms for dots. That's the one where you're looking for a difference, so it has to be subtracting between the 2 terms, and both terms need to be perfect squares. All right, and then the last one that we have is binomial squared, otherwise known as bin squared. That's a shortcut. This one was optional. You didn't have to remember how to do this one, but that would also be used for trinomials. They just had to be perfect square trinomials in order to use the bin squared shortcut. So hopefully that helped you review your methods of factoring, and then helped you remember how many terms that you have. It helps you decide what method you're going to use to factor. So let's check out what our first problem is going to be. So this is a factoring problem, and we need to make sure that we factor this one completely. No stopping on this. All right, so I have 3 terms, it looks like. 4x to the 4th y minus 8x to the 3rd y to the 2nd plus 4x to the 2nd y to the 3rd. So 3 terms there. That should be jumping out some things that we could do, but I always tell my students, no matter what, always look for a GCF first. GCF first. A lot of times it makes a very complicated looking problem much easier to deal with. So I'm looking, what do these guys have in common? What is the greatest common factor? I'm looking at my numbers here, 4, 8, and 4. Looks like I can pull a 4 out of that one. I see they all have an x. In fact, x to the fourth, x to the third, and x to the second. They all have an x to the second in common. And then I see they all have a y, y squared, y to the third. So it looks like what I can take out there is y. So when I'm factoring by GCF, what I want to do is I'm going to figure out what my GCF is. I pull that out front, and then I put my parentheses down and say 4x squared y times what will give me 4x to the fourth y. I don't have to, 1, I guess I don't have to write that, but I need an x squared, and that's it, right? 4x squared y times x squared would give me 4x to the fourth y. How about this next term? 4x squared y times what will give me negative 8x to the third y squared. Well, 4 times negative 2 would give me negative 8. I'd need to multiply by another x and another y to give me x to the third y squared. All right, and my last term here then, 4x squared y times what will give me 4x squared y to the third. 4 is already there, x squared is already there. It looks like all I need to multiply by is a positive y squared. All right, so I took out a GCF, definitely use GCF, but I can't be done if it says to factor completely. What I have left in my parentheses is 3 terms. What was my method for factoring 3 terms? Oh, my binomial guess and check, or in other words, factor boxes. I could definitely check that. Or bin squared, but not everybody remembers bin squared. If you remember it, maybe this would be a place to use it. Most of us remember that factor box, or I'm just going to bring down my GCF here and get my binomial guess and check set up. So I'm going to take this part right here, my trinomial, and figure out what 2 binomials multiplied together to give me that trinomial. Now, if you're in that method of factor box, not everybody is, but this is where I say, okay, in that trinomial, that first term of the trinomial goes up top in the first box. The last term of the trinomial goes up top in the second box. The middle term slides down into this nook. Now, everything on the inside multiplies together to get out to the outside. So what times itself gives me x squared? That's an easy one, x and x. What times itself gives me y squared? That's also an easy one. Y times y gives me y squared. And then when I multiply to get out, x times y gives me xy. X times y gives me xy. But when I add these two together, everything on the outside is added together. I'm supposed to get negative 2xy. Well, that means that this needed to be negative y times negative y. So I get negative xy plus negative xy gives me negative 2xy. And then remember, for your factor, if you're a factor box user, the diagonals are the things that go into my parentheses. So this would be x minus y times x minus y. Now, if you're not a factor box user and you just like to do the guess and check, totally fine. You don't have to do that factor box. That's totally optional. If you guess and check, let's see, if you just kind of multiply it back out, FOIL it, right? X times x is x squared. X times negative y gives me negative xy, negative y times x, negative xy. You add those together, get negative 2xy. Then you do negative y times negative y gives me positive y squared. Looks like it checks out. Okay. That's funny. Those two are written exactly the same. So technically, I could write my answer, whoops, not with a highlighter, would be 4x squared y times parentheses x minus y squared. Either way, though, doesn't matter. But if I get a binomial squared, I could have used the bin squared shortcut. A squared plus 2ab plus b squared. x is my first term, y is my second term, it has to be negative because that middle term up here was negative. And so if I double check that, x times negative y and double it gives me negative 2xy. So it would have been a bin squared. If you didn't want to do that shortcut, you definitely could possibly have done bin squared if you want to use that shortcut, instead of doing the factor box. Okay, whew, that reviewed a lot, so hopefully that brings back your factoring ideas for you. How about this one? Why don't you take a shot at this one? Remember, factor completely, double check that you have everything. You might have to do more than one method. See what you can do. All right, so when I look at this, I see two terms. First thing I always want to look for is a GCF. Let's see, 16 and 25. 4, 5, 2, no, it doesn't look like it. A squared, B squared, my two variables are different, so no GCF for us here. So if I have two terms, my method for factoring two terms other than GCF was dots. The difference of two squares. Is it a difference? Yep. Does it have two terms? Yep. Are both terms perfect squares? Let's see, is 16 a perfect square? Absolutely, 4 times 4 is 16, so is a squared. A times a is a squared. How about 25? 5 times 5 is 25, so yep, b squared, also a perfect square. This is definitely the difference of two squares. So the trick now is, do you remember how to factor the difference of two squares? So this also gives me two binomials. This one was the one where when my two binomials, one is positive and one is negative. That's how when you multiply those two binomials, that middle term cancels and leaves you with a binomial, two terms, instead of a trinomial like our other factor box ones. Then we say what times itself gives me my first term? Well, that would be 4a. So 4a goes first in both parentheses. What times itself gives me my second term? That would be 5b, 5b, and one's plus and one's minus, and that's how that middle term cancels out. So 4a plus 5b times 4a minus 5b. Just double check, are there any GCFs hidden in there? 4, 5ab? Nope, it doesn't look like it. So this is my final answer for that one. We reviewed dots, bin squared, factor box if you used it, or guess and check, GCF. We didn't do grouping, but that one doesn't come up very often. So hopefully that helped you remember this idea of factoring. So let's talk quadratic equations. Now let's talk solving. So what happens when we throw an equal sign in here? Do you remember the ways of solving a quadratic equation? So the easiest way to solve a quadratic equation was using square roots. That usually goes the fastest, right? We know what we're doing on those the most. That's like number one, most preferred method, square roots. The thing with this one is you can only use a square root if there's no, what I call the x term, right? You can only have x squared. 4x squared equals 16, something like that. You can't have 4x squared plus 5x equals 16. That doesn't work, right? 4x squared equals 16. Yes. 4x squared plus, maybe we'll say 9x equals 16. No good for using square roots. So that's the tricky thing there. After square roots, we have the next method we have is factoring. So this one works almost all the time. We can have an x term with this one, or you don't have to, right? It's up to you. You can always use those two term ones, right, like dots, but the square root might be easier in that case. So factoring, you can have the the three terms, but it can't always be factored. Not everything can be factored. So if it can't be factored, then our third option will be the quadratic formula. The quadratic formula works for every single quadratic equation. Always works. But it takes a long time. So it's our last resort. But it will work on any single quadratic equation there is. Now some of you are saying, hey, wait a second, we learned one more method, and that was called completing the square. I kind of lump in completing the square with factoring and square roots, because it's kind of a combination of those first two. You can't do it with every single equation, or I guess you could, but it would be very complicated to do it with all of them. So really you're looking for those perfect square trinomials. It's a little bit more complicated, not one that comes up a lot until we get to circles. But it is one. We're really going to focus on square roots, factoring, and the quadratic formula today. All right, so here's our first one. Now that we remembered our different ways to solve, maybe you guys can take a shot at how you would solve this one. 14n squared minus 24n equals negative 2n squared. All right, well, I see an n squared and an n, which means I can't use a square root. That one's out, right? When I have my plain n term, I cannot use the square roots. So if I'm going to solve by factoring, I have to get it into standard form, right? So that's something we've talked about before. Standard form for a quadratic equation is a little bit different, kind of close to the same. This is ax squared plus bx plus c equals 0. So the big idea here for standard form is that you get it set equal to 0, and then you put them in degree order, meaning the biggest exponent first and down the line until the smallest exponent. So to get this one equal to 0, I need to actually move this negative 2n squared to the other side. So I'm going to add 2n squared. I'm going to add 2n squared. Those are going to cancel. So I get 16n squared minus 24n equals 0. All right. Now, for some reason, once we get here, you guys want to divide by n. Don't ever divide by n. Never, 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 never divide by x or n or whatever your variable might be. You lose answers that way. Don't do it. If you have an n squared and an n, you need to factor. And that, to me, says that we have a GCF. GCF to factor this one. Let's see, 16 and 24 looks like I would have an 8 as a GCF. 8 times 2 and 8 times 3. And then I have an n in both of them. So 8n will be my GCF. What do I have left? I will have 8n times what gives me 16n squared. It would be 2n. And let's see, 8n times what gives me negative 24n. That would be negative 3. So my factors are 8n times 2n minus 3 equals 0. So when we solved by when we were factoring before, that's where we quit. But now I'm solving. So remember, if you're solving by factoring, you take each factor. 8n is one of the factors, and I set it equal to 0. 2n minus 3 is my other factor, so I say 2n minus 3 equals 0. Because when I'm multiplying these two things together, if either one of those things equals 0, the whole thing equals 0, making my equation work. Now, I am very picky that I make sure everybody writes these steps out so that you show me where your answers come from, and don't just jump magically to answers, because it's very easy to lose negative signs that way. So I divided both of those by 8. 0 divided by 8 is just 0. So n equals 0 is one answer. I add 3 to both sides here. I get 2n equals 3. I divide both sides by 2. So I have n equals 3 halves as my other answer. And if you don't show the work on this, it's very easy to get that numerator and denominator goofed up as well. All right, so remember, by factoring, if you have that n term, set it equal to 0, get it in standard form. Don't ever divide by x or n or whatever your variable is. Factor it out, look for that GCF, right? And then whatever your factors end up being, take each factor, set it equal to 0, and solve it out. All right, here's our next one. 9r squared minus 9 equals 40. Go ahead and take a shot at this one. So if I look at this, I have an r squared, but I have no r. So that means I'm going to use square roots. Woohoo! That's the fastest, easiest way to do this. So if I'm going to use a square root, that means I'm going to try and get that r squared, or whatever is squared, all by itself. So the first step is to move this 9 here. I get 9r squared equals 49. And then, oops, I'm going to divide both sides by 9. Don't take a square root until whatever is squared is completely by itself. So I have 49 over 9. And now my r squared is isolated, so the opposite of squared is to square root, so I'm going to square root both sides. Square root and squared cancel out, so I'm left with just r. On this side, the square root of 49 is 7. The square root of 9 is 3. Remember? However, 7 times 7 is 49, but so is negative 7 over 3, right? So I could do positive 7 over 3 times positive 7 over 3 gives me 49 over 9. Negative 7 over 3 times negative 7 over 3 gives me 49 over 9. Or in other words, I could have plus or minus 7/3. You could write it this way. You could write it this way. It really does not matter to me. Both are acceptable. So just remember, no decimals here either, right? You get a crazy decimal when you type in 49 over 9. Fractions, fractions, fractions in this class. Fractions are way more exact than decimals. Don't switch into decimals unless the problem started with decimals. All right. Okay, so we did square roots, we did factoring. How about this quadratic formula? Do you remember the quadratic formula? I hope that most of you remember that song. I think there's about 12 different versions of that song out there. Mine is x equals negative b plus or minus square root of b squared minus 4ac divided by 2a. Whatever your song is, I'm sure you're a better singer than I am, but hopefully you remember that quadratic formula from last year. Be careful that that fraction bar goes over, or under, I should say, the entire top of that, and then 2a is on the bottom. So the second thing is the discriminant. Do you remember what the discriminant is? So the discriminant tells you the number of solutions for a quadratic equation. So it tells you the number of solutions. And the part of that quadratic equation that tells you the number of solutions is whatever is inside the square root. So b squared minus 4ac is the discriminant. Okay? So b squared minus 4ac, just the stuff that's inside the square root, is the discriminant, and that's what tells us the number of solutions. So if you remember back to last year, if that number was positive, if I had a positive number inside that square root, I would end up with 2 solutions, plus whatever it is and minus whatever it is, because I have the plus or minus right here in my quadratic equation. If whatever I have equals 0 exactly, then that plus 0 and minus 0 give me the same number, so I end up with only 1 solution. And if I end up with a negative number inside that square root, can't have a negative inside a square root in the real world here, so that would tell me that I have no solution. So that's what the discriminant is, and that's how it helps us figure out the number of solutions. It's just that part that's inside the square root. Oops, sorry about this. There we go. Okay, here we go. So this problem says find the discriminant and then tell me how many solutions there are. Hopefully this is something that comes back to you quickly. Why don't you take a shot at finding that discriminant? All right, so the first part of it is when we use the quadratic formula, or if we're finding this discriminant, we have to be in standard form. So we just talked about it a little bit earlier, but again, ax squared plus bx plus c equals 0. That's where the a, b, and c come from for our quadratic equation, so we have to line everything up. So it looks like I need to add 2x to both sides. There's already an x, so I can line it up. I also need to add 9 to both sides. There is not a plain number, so when I add that, it's going to go different. Remember, for standard form, they need to be in degree order. So 8x squared comes first. Then I have 8x plus 2x gives me 10x. Then I have my plus 9 equals 0. Now, I'm kind of picky when I have my students. I make them write out what is A. So in this case, A is 8. What is B? In this case, B is 10. And then what is C? And in this case, C is 9. Be careful if there were any negatives in there that you would have to make sure the negatives go with the number. That's why I make them write it out, but it's up to you. So again, we're just using the discriminant on this one. So again, the discriminant is just the b squared minus 4ac part. Don't do it all. That's way too much work. So I have 8 squared minus 4. Oh, sorry. Whoops. Oh, caught it. Not 8 squared. I need b squared, right? B squared is 10 squared minus 4 times a, which is 8, times c, which is 9. The color kind of helps me. That's what jumped out at me right away, that I shouldn't be using the same color twice. All right, so b squared minus 4ac. So 10 squared gives me 100. Let's see, 4 times 8 times 9. Let's see, 4 times 8 times 9. 4 times 8 is 32. 32 times 9. Let's see, that would give me negative 288. So 100 minus 288 gives me negative 188 as my discriminant. But it also says, how many solutions would that be? If my discriminant is negative, that means I would have no solution for this problem. All right. Our last problem here before we wrap it up is to make sure that we can actually solve this using the quadratic formula. I know you could go ahead and try this one. I just gave you a hint. You know, usually you could try and factor it, but I'll give you a hint that the factoring isn't going to work. So I just want to make sure that you can actually solve by quadratic formula. So go ahead and try that. All right, so like we said in the last one, we need to line it up in standard form, which means I need to subtract 7x from both sides so I can get it equal to 0. So I have 5x squared minus 7x minus 19 equals 0. I write out what all my different variables are going to be. So I have a equals 5, b equals negative 7, 5, b equals negative 7, c equals negative 19. All right, so now if I'm going to start my quadratic formula, I have x equals negative 7. Notice I'm using parentheses here and keeping all those negatives in so I can double check my work, plus or minus the square root of b squared, b is negative 7 again, minus 4 times a, which is 5, times c, which is negative 19, all divided by 2, a, which is 5. All right. Now I'm going to go through and start checking things off a little bit. Let's see, 2 negatives here is a positive. So I have x equals positive 7 plus or minus. Let's see, negative 7 squared gives me positive 49. Everything squared becomes positive. I have negative 4 times 5 times negative 19. So again, 2 negatives make a positive here. So it's going to be plus 4 times 5 is 20. 20 times 19 let's see, 20 times 19 would be 380 divided by 10. All right, so 20 times 19 is 30. 380 times 19, just double checking I did that right. Okay, now I'm going to simplify a little bit more, so I get x equals 7 plus or minus the square root. Let's see, 49 plus 380 would be 429 divided by 10. All right, now the next thing we would do is we would try and do the square root of 429. If it was a perfect square, awesome. If it's not, then if it doesn't tell me to round, I would simplify that radical and leave my answer exact. But here it says to round your answer to the nearest thousandth. So hopefully remember that thousandth, that's 3 decimal places. Since I'm going to round it anyways, I'm not going to spend the time trying to simplify that radical. I'm just going to split it up. So I now have 2 possibilities. I have one possibility, I'm just moving one direction and then the other. So one possibility where I have 7 plus the square root of 429 over 10. And I have a second possibility where I have 7 minus the square root of 429 over 10. So I'm going to get my calculator and I'm going to type both of those in. Let's see if I can pull one up right quick. I can't. Okay. So get out your calculator, type those in. I don't mind my desktop here. I'm going to get my calculator going. Okay. All right, so we need to do 7 minus the square root. Oh, sorry. Okay, so this gets a little bit trickier then. I need to do the square root of 429, right? Now, normally, I don't like to round anything before. I would say type in 7 minus the square root of 429, hit enter, and then do divided by 10. But in this case, my calculator is a little bit different. Yours is probably like this. Maybe I can switch it over. Ooh, here we go. How about 7 minus the square root? Nope. 429. It's still not working. All right. So I've got the square root of 429 is 20.712315. I'm going to leave a couple of extra decimal places when I type this in so that when I round it, I don't get off. So 20.712315. So I have 7 minus 20.712315. And then I'm going to divide that by 10. So I have negative 1.37123. So I'm going to round it to negative 1.371. That was the minus, right? I feel like I've already forgotten. Negative 1.371 because I'm rounding to the nearest thousandth. Okay. And then I'm going to do, just to double check again, I need the square root of 429. 20.712315. 712315. So I need 7 plus 20.712315. And then divide that by 10. Notice I'm hitting equals in between, so I have 2.771 if I round to the nearest thousandth. 2.771. So those are my 2 answers, negative 1.371 and 2.771, because I'm rounding to the nearest thousandth. Be careful when you're typing that into the calculator. That's only if it tells you to round. If it doesn't tell you to round, we're going to leave it exact and we're going to simplify as much as we can and call it good. But occasionally we'll need to have it rounded answers. All right, that ended up a little bit tricky, but hopefully you were really comfortable using the quadratic formula up to there and then probably more used to using your calculator than I was even on that. So wrapping it up, factoring polynomials, remember to always look for GCF first. If you forget, look at your parentheses before you're done. Solving quadratic equations, square roots are the fastest, but you can't use them if you have a plain x term, and don't ever divide by x. Factoring is much faster than the quadratic formula. Don't forget to try all methods of factoring before resorting to the quadratic formula. That discriminant tells us how many solutions there are. It's just the part inside the radical. Positive is 2 solutions, 0 is 1 solution, negative is no solutions. And then your homework for tonight, again, is a homework worksheet. That should be a link on your copy right there. And if you need any extra practice on any of those topics, you have that guided practice worksheet to use to help you out, to help you ask your teacher questions if you need it.